Okay, so just recently I've been doing a bunch of work off stream, in fact, on various things to do with loading shared libraries, and things are looking much better now. I've got it mostly working for both on-demand DLOpens libraries and the libraries that are defined as runtime dependencies. The main things I've been adding on to that have been the ability to switch between source files when you've got multiple libraries with debug information, and also the binary disassembly. Now I'm just going to look at a... Oh, I keep doing that. I'm going to look at a bug with attempting to put breakpoints into anything other than the executable. So at the moment I have a program that involves a shared library load, and the code on the left pane here is from the shared library we've called into already from the parent program, like the executable, and it's correctly showing the source file and the disassembly of it, but I can't add a breakpoint on line 7. So I've set it up so that the GDB on the left here is stopped inside the code where we handle the key press for inserting the breakpoint, and I've just been stepping through trying to work out what's going on. So I think I have spotted the problem, which is I haven't converted all of the pieces of the debugger to understand that there is more than one binary available. So in this code here, we've got, if you have pressed down the insert key, this frame, then it wants to check out, okay, which line is the source of the source code are you on, which is stored inside this text cursor position, and it adds 1 onto the line number because the text cursor position is 0 based, whereas line numbers are 1 based inside DWARF. So that's what it's going to use to kind of indicate the correct breakpoint line. Then it's going to make a call into this debug line infos for line. So this is going to give back a structure which describes which of the machine code instructions, or the offsets to those instructions, are linked to the line we're looking at, if there are any. So what we should get back here is our result, which says like how many lines did we find, or how many instructions did we find that corresponded to the current line, which is line 7. So immediately, because I know I'd recently changed this, I spotted that we're using this, we're getting the main memory, looking at the executable, which is the file that we've loaded into the debugger, and we're pulling out the decoded binary, which is my structure describing both the ELF content and DWARF content as kind of structures in memory. So you can see that it's not really carrying which binary we are, or which source file we're looking at, and so this should really be worked out by looking at either the disassembly pane or looking at the source pane and working out which binary they correspond to. I think there might even be somewhere else where I'm storing the concept of the currently selected binary. But I think, thinking about it, I've been using the binary disassembly pane to store this. It's probably not the best place, but that's what I've been doing up to now. So I just want to check through if there's any other places where I do this kind of, I use the executable instead of the currently selected binary. So we come into here, we've got more than one line, we're just going to find the first instruction and we're just going to break on that. So for line 7 it's going to attempt to break on this no op here. Then it's going to, so we've got some temporary memory around this because this debug line infos allocates some memory to return this result, and because it's like, it could be a very varying size, so we want to throw that away. Now interestingly, this is inside the if statement, and that's because I happen to know that if the line count is 0, it doesn't allocate any memory. So then what we're going to do is describe a breakpoint. So we create a breakpoint structure, tell it what instruction we want that breakpoint to be written to in real memory, but then we also want to convert that real memory instruction into an offset into a particular executable or binary, because it might be a library. And here we're using this executable here, but that first argument I think is supposed to always point to the executable, so that's okay, because the list of libraries, loaded libraries, is stored on the executable. And then it's also passing in the debugger because it needs to use the extra information about where various libraries are loaded in memory to convert this instruction. So what this debugger has is another list of libraries, but they are a list based on looking inside the actual debugger process and asking it, okay, which libraries do you think you have loaded? Whereas the list inside the executable is where we've looked at the file on disk for the executable, found which things it says it needs, which the runtime linker will load, and then tries to recursively resolve those and load the information about the code for those files and any debug information and alpha information like symbols, load those all into debugger memory. So that doesn't necessarily tell you where those libraries are loaded in memory inside the debugger. So that's what this structure is going to contain information for. So that will have a list of all of the shared libraries. And if we detect, actually in another part of the code, if we detect that a new shared library has been loaded with DLOpen, then we add information for that shared library into the main list, because it's then going to go off and find the file on disk, load it in, load any debugger information. And yeah, the instruction to make that's the memory address in the inferior, or the debugger, which need to be converted so that gets compared against where the extents of the code sections of the executable are. And if it's in there, then it's okay, it's this offset inside the executable file or code region, and then it also looks through all of the other libraries that it knows about and says, okay, I know it's loaded at this address, and this is the offset into the code region. And so it checks within the extent of each of the libraries to say, okay, I know which ones that is, then it does the calculation to find the offset inside the code region, which means you can then always go and look at the file version of that and see exactly which piece of code it's looking at. I do still need to update the disassembly view. So this disassembly view on the right here is looking currently at information loaded from the files on disk. But if you hit tab, it moves to memory view, in which case it's going to actually want to look at the real memory address and read out of the debugger all of the memory addresses. Whereas when you're looking at the normal view, it's showing you what's the contents of the file is, and that's where it needs to know what these offsets are. Previously, it didn't need to know any of this stuff, because when you're looking at the executable only, then inside the binary file it tells you where it's going to be loaded at, and actually all of the addresses are relative to the address that's called the code base, or I think I've called it the base code address. But when you are talking about shared libraries, they're position independent, so they can be loaded in different places, not just where it says inside the file. So you need this extra piece of information. Anyway, I've rambled on enough about that. We need to go fix the problem here. So what I'm going to do is, I think I'm in the right place here. Oh no, I'm not in the right place. Yeah, here. So where we've got the same piece of code I was looking at in the debugger. So we just need to, I think we really just need to fix this here. So do we have a pointer to this assembly frame pane? Don't think so. So if I recall correctly, it just looks like that. Oh no, for this one, for panes, they have file on the end. I'm not sure whether I like that, but okay, so that's compiled. The debugger's probably going to crash now if I were to continue, because I added an invalid code path here inside the hot reload code, because none of this hot reload code's good anymore. In fact, it wasn't really good before. It's been a long time since it's actually done anything but horribly leak memory. But now it's actually going to end up creating binary file information, or decoded binary file information, which has kind of moved around. It might end up reallocating it, and then it's not going to meet up with the list that we have for all of the loaded libraries, and so a bunch of the checks that rely on those pointers not changing are going to fail. So I need to fix this at some point, but for now I'm not too worried. I'm just going to rerun the program and get back to where I was. So this is actually the program that I'm running, and all it does, I think I showed this last stream, is it tries to DL open this shared library that I've created, which defines this hello function, just I think prints hello out, which is the other program we were showing. So it's just doing a simple lookup and load of that library. And this is just to test the detection of a library being loaded at runtime. So obviously when you load the executable here, because it's not running, it's not started the process yet, and yet you can still look at a lot of the information, but it doesn't know about this library yet until you run it, which I'm going to do now by starting the process. And then it's going to move to this breakpoint that gets automatically inserted. I'm just going to create a breakpoint in here. It's fired off this GDB breakpoint because I said to do that every time you add instruction. I'm just going to continue to that line, and then I'm going to next instruction until we hit the call here, and then I'm going to hit a button to jump to the currently executing instruction. So now we're inside the DLL and we're seeing the binary and source file for that. So that's all the stuff I got working over the last few days, and over the weekend primarily. So the thing that wasn't working was being able to set a breakpoint in here. I'm actually not sure why this is showing up as a breakpoint, this line 5. I'm tempted to go and have a look at that in a minute, but for now I'm just going to try and hit a breakpoint at 6. Okay, so we're now inside GDB. Just going to scan through here to make sure everything looks like it's working. Oh, actually, I thought I'd set the breakpoint in the previous instruction, but I didn't. I set it in the point where we're actually going to add the breakpoint, so I'm going to have a quick look at it. Breakpoint to add. Okay, this doesn't look too good. That instruction address is not looking healthy at all, and which is probably why the instruction location there, which is the converted instruction based on like which binary and code offset it is, they're both 0. So I suspect it looks like it's going to allow it. There's no check in here to say that that's not okay. So it's going to create the breakpoint and add it, but it may well now crash if I continue. Yeah, so it's tried to read from the address where that breakpoint was set, and it's failed because it's not in a valid piece of memory. So it's trying to read from address 1700 in the debugger, which is no good because that is not a valid address. So something here has gone wrong. Actually, I'm not going to quit, I'm just going to switch here. So the problem is this instruction address has come back incorrect. Now thinking about it, this is probably not an address, this is probably an offset. Now when you're looking at a library. So this is the problem you have when you're looking at the executable. Everything kind of looks like the address it should be, because the address at which the code is loaded for the executable is set to where it actually gets loaded. There's 0 offset from where it asks to be loaded. Whereas with the shared libraries, quite often they'll have some small number as their offset, so that when they get loaded into memory, there'll be that offset from the start of the place where they were loaded. But it's all relative to the start of where the library was loaded, so you need to then go look up where the load address is. So this is actually really an offset that we should be dealing with here. And in fact, it might be worse than that. It might be a slightly adjusted offset, because the code segment isn't at the start of the file. So this is why you have like a base address that's a certain number, and then on top of that you add on the instruction offset into the code array, or the code area, and that whole gets moved into a particular point in memory. So I just probably need to change the way that these debug line infos work. So I know I'm just going to get rid of this annoying window here so I can use my whole screen for the code. Because I want to look at the header file now and see what that structure looks like. So it's called debug line infos. So there is an instruction offset in here. I just want to check, is that going to be the fact that I've just taken the base address from the file off of that. I'm going to split this down here and have a quick look at, what was it called? Debug line infos for line. Because in there we're going to get the code that produces this. So this is just a lookup. What we want to do is look at where this is built. So this one, file instruction info. This is kind of similar to the way that we were building source file information, where we were scanning through the source file, working out where the line endings are. No, this is the wrong one. So this builds the, as I was going to say, this builds the equivalent of the line ending, but for the binary instructions, because instructions can be of variable width. It can be 1 byte, 4 bytes. So this just marks like how wide each instruction is, so you can look up any particular instruction within the segment and work out how wide it is. But what we wanted was the other thing, which is where the line information is, which is the mapping between the instruction addresses and the source code, which is in binary file. Is it build in here? No. Line info. In fact, I think the reason why I have an instruction offset there is because I actually added it in recently in the last few days. Yeah, so this is the line which does the business. So you can see it's just taking the instruction address, which isn't the real address inside the debuggy, because this is read from file. This is the address according to the base code address. So you take the base code address away, then what you get is the instruction offset within the code region. So it is exactly what we want, I think. So let's get this back. So we want instruction offset here. Oops. That is not the instruction to break at. We need to add on. Now maybe we do want the instruction address, but then we need to add on the load location, the load address for the library we're looking at. Now, that's what this is supposed to do, isn't it? No. This does the other thing. So instead, it takes a real address inside the debugger and converts it to an offset. But what we have is kind of almost a real address, but it's the real address without the load point added on the front. So it will work for the main executable, but it's not going to work for libraries. So I don't think I have something which takes this kind of address. So we can construct an instruction location, but then we need to get back to the instruction address, because the breakpoint needs to know the actual instruction address to insert the breakpoint into in memory. So maybe that's what I would want. Maybe I want to know the base code address here, which is the main disassembly pane decoded binary file. Bit of a mouthful. And then we want to grab out of the binary file the base code address. Okay, and then here we can take the instruction offset. I've made the instruction offsets 32-bit offsets. So I'm assuming that any individual library is probably not more than 4 GB, but maybe that's a stupid thing to assume. It's not too much hassle if I need to change it though. Okay, so I can now create this instruction location. I think I even have a function to do that. Do I? Instruction location. Maybe I don't. Can't remember if I've already looped around this file yet. I think I must have done by now. How about instruction location? I'm sure there's somewhere I have to construct one of these objects. So obviously in here I did. So this is doing the search that I mentioned when you've got a real address. It's going to say, okay, are we actually in the main executable? If we are, then all we need to do is take away the base code address. Or if we're in a library, we need to go find the library in the debugger, and we need to take off the base code address, but also the load address. Yeah, you see the base code address on the file plus the load address. Okay, that wasn't the one. That isn't the one. Nope. Nope. Okay, so maybe we don't ever construct one of these. In that case, now is going to be the first time. Instructional location. Let's see what's it made of. It's made of a binary file, which we know. I think we should store that up here. So we'll have like decoded binary file, binary. And we'll just take the main. In fact, stop being lazy and just grab it from here. So our instruction location is just going to be the binary and the instruction offset. Then our instruction to break at, let's pop that underneath there. get instruction address. We're going to need to pass in the executable. It's going to be the same thing, but that's going to be the reverse operation to get instruction location. So we need the executable, and we need the instruction location, and then we need the maybe that's all we need. Oh no, we need the binary as well, right? So this instruction location is actually going to be put straight into here. So that, I think, should do the job. So if we look at get instruction location, we want internal U64 for our instruction address. Get instruction address, and we can basically just copy that signature across, but instead of the instruction address we've got an instruction location here. So most of these calculations we're doing with the get instruction location and now with the get instruction address are going to be cached inside the breakpoint, so we won't have to calculate them multiple times. So even though it's a little bit slow, doing all these loops and checks, it's only going to happen infrequently. So this is basically going to be the same sort of thing, but a little bit different. So U64. So we need to check. What we need to check is kind of want to check if instruction location dot binary, a decoded binary, is that what I called it? Yeah. If that's equal to the executable decoded binary, then we're inside the main executable, and what we need to do is simply return the we need to set result equal to instructional location dot offset, and we want to add on the executable. So we can just instruction location dot decoded binary dot. So let's give it a pointer, I think. Base code address, right? Because for the main one, we don't have an unknown location. It's always loaded exactly where the base code address is. So I think that's all we need there. So otherwise, we need to do some of this code, I think. Let's grab all this, stick it in here. Don't think we need to check that. So this means it must be one of the other types of library. We're going to loop through all the libraries and I think we can just... Now may be a good time to enact this to-do. Actually, now I'm in this code. Always leave the code better off than when you first arrived. So I actually want to check here what this get loaded library call does. I think it basically does what that piece of code is doing. Just need to match start of line. No, it's not in there. So maybe it's in debug CPD. Nope, maybe it's in debug action. That makes more sense actually. Here we are. Yeah, so this is the one. So let's just check, what does it do? It goes through the debuggy's libraries, checks to see if the file name matches, and if it does, it returns the file name and load address. So what are we doing? We're going through and we're checking So we already have the library, the kind of file library. I haven't given them good names here. So what we want to do is do get loaded library on our debuggy, which we have. And we want to give it the file name of the library we're interested in. So that's going to be in the instruction location decoded binary file name. I think that's the pointer, isn't it? So we say get me the library from the debuggy, which has the same name as the library that we are looking at an offset to. And that's going to be a loaded library. Library. So that's all we need, right? That's the information that we need is, firstly, give loaded library dot valid. I'm going to check this actually found it. Then we need our result to equal basically this. It's kind of tempting just to make the result equal to that, right? Is that a good idea? No, it's probably not a good idea. Thinking about it. Because we kind of want it to be 0 if it's not equal to the main library. Okay, so let's just leave that like that. Yeah, that seems fine. That a 0 instruction address would be if we didn't find it. So we want this, and we want to add on top of that the loaded library load address. Nah, I'll just leave it like that. I'm just don't like the way this is formatting. I was thinking about splitting it out into multiple variables, but I'm not sure it's important enough. Okay, so let's just get rid of some of this white space there. Does that compile? No, I need to spell things correctly.
Extended initialize lists. Ah, yes, of course. Probably easier just to do it this way. Okay. Can I convert decoded binary file to debuggy? So this is in debug action, debuggy, I think. That's right, because the binary we were after is inside the instruction location. We didn't need to pass it as an argument. Okay, so no errors now. I feel like that should fix that problem. So let's give it a go. Let's break at... Actually, I'm going to run it and pop this over here first. I'm going to break at... It's at 2543 Android per CPP. Let's grab a breakpoint there. Start the process. Could you print out anything when I start the process anymore? I just noticed that. Okay, so now we are in here. Can I create a breakpoint? So there's our instruction offset. Step into this function. That should be no. This should see if we did get a valid library. What's it called? Oops. That's really annoying. There we are. So it is the correct library. So I wanted to check. Let's see what our result is. That's not good. Oh, it hasn't executed the instruction yet. There we go. That's better. That's not right. Okay, apparently that is it. Oh, it's a 64-bit address. There we go. That looks better. That is a place where we want to break, and that is indeed the correct location according to this disassembly view anyway. So that's good. So we add the breakpoint, and yes, it worked. I say it worked, it's now crashed. Where has it crashed? Handle debuggy code read. Okay, so it's crashed disassembling. So it's crashed over here. So let's just pop up a stack. I think I know whereabouts it is. So this implies to me that this lower down... Oh. This lower down function Oh no, that's not the right one, so let's go up again. Get there eventually, there we are. This is the disassembly pane. Oh, render memory disassembly pane content. Why is it rendering this from memory? Did I hit tab by mistake? Maybe I did. So this is the code I said at the start of the stream wasn't working. So what I think I'm going to do is run this again. Let's hit a breakpoint down here. Oh, I need to clear this breakpoint, which is disable breakpoints 1. Continue. Okay, here we go. So open this up, launch, step in. Oh, interesting. It's drawing the breakpoints not quite right as well, I think. So when I hit insert, okay, I must have accidentally hit tab because that's working again now. That looks just right to me. Now this red line is correct. Okay, so I had thought that there was a breakpoint on line 5 automatically added somewhere, but it wasn't. It was just the currently executing line. So I just want to try changing to this source file. Now, this source file says that line 6 is the currently executing line, which is not correct. But that's because it's actually line 6 of the shared library that's running. Okay, so it's like this particular instruction which is mapped to line 6, which will those square brackets mean. And now when I'm looking at the other file, it says that we're on line 8. That doesn't make any sense. So I'm not sure why that's showing up there. I'm tempted to kind of just like break in this render text source, something like that. I think it's called render text pane actually. Right, render text pane content, that's what we want. You just get into my breakpoint and see why it's doing that. So it's probably I just haven't updated this code either to recognize libraries. So here we go. It's going to go through each of the lines. It's going to draw the cursor. That seems to be working. Okay. It's going to look for breakpoints. So this is being converted already because it's using these instruction locations which are new, and it's checking is the binary that is linked to the source file I'm looking at the same as the binary recorded against this particular breakpoint, and if it's not, I'm not going to show it. So I think that's just showing the correct things. So now we're doing draw executing line. So are we debugging? So this is bad, right? This is not correct. It's trying to get the debug line info, but it's not at all checking that the binary we're looking at is the same one for the instruction location of the current thread. So what it's doing is it's getting the code offset for the DLOpen servant shared library, and it's looking up the instruction within the library attached to the pane, which is the DLA from the master executable. So that's the bug there. Let's go fix that. So it's just an extra condition here, really, that our pane text file binary is equal to our main current thread instruction locations binary. Decoded binary? I think it's decoded binary. Okay. Yeah, so we only want to do that lookup. This just looks rather long. I was tempted to pull this out, but then I realised that you should only do this if you're debugging, because that current thread is not going to be there if you're not debugging. It's either not going to be there or it's going to be stale, which is even worse. So I can't really do that unless I do a separate if statement here. That still applies. Draw the execution line if it. No. I think that's kind of clear actually. I am going to do this as two separate things now. I've just decided, because I can clean up the code a little bit more if I do. So what I'm going to do is say that the decoded by no instruction location current or executing location. Oh, I have to call it executing, okay. That equals the main current thread instruction location. Then we can say if this is true, if the binary we're looking at is equal to the executing, I think I'm going to call it executing location actually. Oh, no, that was right. So if we are looking at something that's in the current file, and do all this. I think what I can simplify is here we can say is everything else good? I think it is. Yeah, let's give that a go. Then I think I might fix the hot reloading. What time is it? 52 minutes. Okay, if I have time. Indeed not a pointer. No errors. So let's see the reloaded, core reloaded thing. So what we want to do when we reload the core file. try and check why we do this. I think the reason why we're doing this decode binary file is because if I had changed what decode binary file would decode, then we'd need to repass the binary. Annoyingly, I think what I want to say is I could just clear the binary arena if I wanted to do this, and then reload it, and it would almost all be fine, apart from those pointers would change. I am actually just tempted to just comment this out, right? Because it needs to be done if we change the decode binary file. Although when we were debugging the debugger, it would be important to repass the file because, or no, it would be important not to, because it would depend whether you launch the process or not. Because they'll be out of sync, right? If you're debugging the process, you reloaded the thing, and the thing that you were reloading was actually itself, then the binary on disk would change with the new code changes, but the running process would still be using the old file. So if you reloaded the binary, it would then be out of sync. But if you didn't reload the binary, maybe it would be fine. Yeah, maybe it would be fine. So probably not reloading the binary is the better thing to do. Okay, I'm going to do that, and hopefully that will at least make the reload work again, although we'll see if there are any problems with things needing to be properly reloaded. I should think I don't need to do anything here, but hit continue. Well, no, we crashed, so I need to restart. Okay. Let's try again. Continue. What happened? Just disable that breakpoint. Disassembly. Let's do our breakpoint, launch, continue, next. Continue, that works. I wanted to change back to here. Okay, so now it doesn't think that it's still executing line 8 anymore. But it is now highlighting the lines for the wrong thing. So when we changed file, we didn't change the binary, which it probably should, but if we hit space it should take us back. It did not take us back. Okay, another bug. I suspect the bug here, yes, it only tries to change the source file if the binary has changed, which isn't correct, I think. So I'm just looking through to see whether I can just get rid of this check to binary changes, because the reason it's there, I think, is to prevent like scrolling glitches. Like, what I don't want to happen is to have like a file that we're looking at some point in the file that when you hit space and you're already on that file, it scrolls from the top or some crazy thing, which is a bug I used to have. But actually I don't think this is a problem. So what is binary? Binary is the binary from the currently executing thread that we want to jump to. It's because we didn't change this right pane, but we did change the left pane. So if we fixed this right pane to be linked to our left pane again, then this code would work again. I'm not sure if I want to keep that though, that those two panes are linked together, especially when there's a way to select which of the left panes you want to look at. Oh, I think that's a problem for another time. It's probably actually better just to make sure that when we change the source pane, we change the disassembly pane for now. I can fix anything else in a feature. Why is there a little glitch down here though? That's weird. What's causing that? I think there's a little line running through. You see it just there? I think it's the same line that we have up here. I think these titles are actually misaligned slightly. Probably broke them, because this is supposed to be like a status bar that you can write things into. But it looks like the titles are misaligned. I'm going to take a note of that. Okay. Just going to go and say that when you hit Control F, which would be there we go. Control F. Then when you hit the Enter key, so when you do Control F, it puts you into capture mode for file select. In capture mode, when you hit Enter or Return, it switched to source file by index, but it should also switch to the corresponding binary. TBLODT. I don't know how you say your name. Can you tell me about why you're making your Linux debugger? I am making my Linux debugger because it's a good learning exercise for a start, and I wanted to see if I could make a debugger that responded more quickly than GDB-based debuggers do, and was less awkward in terms of an API to program to. This was, and in fact it was quite a long time before I realised that there is a much better programmatic interface to LLDB than there is to GDB, from what I understand. That's what I hear from other people anyway. I only looked at GDB though. Right, so to fix this, certainly there's a lot of front-end improvement that can be done. But I decided to go and learn about how the back end of the debugger worked, which is a lot of work, but it has been really interesting. It is a from-scratch ptrace based debugger. So do I want to just put this into switch source file? It feels like I shouldn't put it into there. Even this is no good, right? Because this only allows us to select from source files which are in the executable, but there could be debug information for all sorts of other libraries which we can select from. I think that's a whole other feature that needs to be done though. So for now, I think it's safe to say that you should just switch the binary back to the one you know you can get, which is the executable. So, so main source pane binary. Going to set the main executable. Try to remember where this is. I think it's just decoded binary. And we also want to set the main disassembly panes decoded binary. Use that as well. Decoded binary file. I think that it's actually in text file. This lives, yeah. I really need to kind of standardize on what I call this field. So just check. Oops, that's not what I meant to do. I wanted to go to the end of this one. Check I had this called source pane, that's correct. So what was it complaining about? I think I'm going to have to quit the process because of this rendering glitch, which I've never worked out why it happens. It just happens when I'm running it on a virtual machine. It doesn't clear the window away when it's lost focus. Okay, so press remember binary, blah 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 blah. Text file star. Maybe you meant to use a pointer. Is it this one? Or was it the other one? It was that one. Okay, so what's the other failure? Press remember decoded binary in executable, which is of type pointer. Okay, so maybe that's supposed to be that. And maybe you need semicolons at the end of lines in C and C++. Just a guess. So what was I fixing there? Let's get rid of that. We were fixing file select, weren't we? So grab that. So I think I just want to set a breakpoint here. Step in, move to here, change back, and it all works. But it doesn't remember where you were, which is kind of annoying. Hit space, change back here. That's cool. So that's fixed that problem. Right, time is just over an hour, and it's nearly bedtime, so I might just have a quick look at this graphical glitch down here, and then call it a night. So graphical glitch will be in render title probably. Certainly render something. Maybe it's layout title. Render a pane title bar, obviously. Move the baseline adjust. No. Oh, I already had a note saying that it looks incorrect. I think I was going to come back and look at this. So if I recall correctly, there's this command bar height which needs to be added in places. I think what I want to do is change this colour. What other colours do I have? So I want to see how big these things are. I think the pane background, like, I don't know, white or something. But then let's make this rect outline. I think that's this one. Let's drop the rendering of the title for now. Why does that happen? So I think it's just that the panes are too large by the look of it. They shouldn't overlap the bottom here, which is to do with, what's that to do with? That's bar bounds. Where's bar bounds worked out? Oh no, that's all fine. I think it's just this incoming pane bounds that's incorrect, which means that the layout is incorrect. That looks fine. That's going to be fine. I think it's just the layout. Okay. I think what I'm going to do is I'm going to make... Let's make the title have an outline as well. So render title bar in pane. Make this a false as well. Right, hold on a second. I'll be right back. Right, sorry about that. Yeah, so let's make those outlined. That's better. I think you can see that a bit better now. So I just need to go look at where we've got the layout code. Okay. Okay. So this is setting up like the percentages for each of the panes. Right, so if I go over here and can I open panes? Alright then. See, that's like 30% of the screen. Well, those totally overlap as well. Probably for the same reason, right? Now, somewhere down here, actually work out the available screen area for panes somewhere. Right. Okay, so this is it, I think. Specify the top left extent to be the left pad on the screen, which I think is this tiny gap here. Then tab height collapse, because I was going to have tabs at the top here, so that's that bit there. And then so this is top left, and bottom right would be. I think that's a problem. Yeah, that's a problem. No, it's not. It's two screen dimension, that's fine. Right, so that's the bottom right here. And you take away screen pad right, which is that tiny amount. Then we take away the command bar height, which is 20 pixels, right? And then we take away the screen pad bottom, which has got to be another small amount. Oh. Is that mean it's going to add those on? I think that's the problem. This needs to be an add. There we go. Simple problem. I think that's fine. Let's go revert the other changes. So here we want the pane titles to be solid. And we want these to be solid as well. And of the correct background colour. Kind of want a little gutter between the panes as well, honestly, but this is what I have to do for now. That and these things overlapping is kind of annoying. Okay, that looks like these render off the bottom of the allowed pane, or the pane doesn't have a clip on it or something. So that's another bug that needs fixing. Yeah, I can quickly take a look at that. So this is the render watch pane. Oh, I forgot there is actually a process running. But there are no scopes with variables in here. I assume it worked correctly. I do need to check that we get watch pane information for shed libraries that have debug information. So if we're debugging, what do we write if we're not debugging? Do we write a message? Apparently not. It's a bit mean, just an empty pane. Okay, so there's no clip. That's the first thing I noticed. We haven't set up a clip. I feel like the other ones did. No clip on that one either. Render text. So this one sets up a clip. Oh, that's interesting. Cool. That's obviously some debug. So for the render watch pane, and I think the threads pane. See what that looks like. That seems better. Okay, I think I'm going to call it there. There's a couple of things I want to add to my list here. So let me just check some things off. File select window list files from other binaries. I haven't done that. Binary select, I haven't done that. Insert breakpoints in other binaries. We did fix that. Memory disassembly, didn't get around to that. Show message when no source is available for currently shown binary, didn't get around to that. Binary scroll not working, didn't get around to that. Refactor. Always refactoring things that finally work for now. No, all the other things are kind of bigger. Paint items too low, did fix that. Okie doke. Let's check that in and call it a day. Oops. All the changes are in main. So we added the reverse mapping there, added some clip rectangles. What was that? Fixed the rendering in the debug pane, or in the disassembly pane and the text pane. Re-enabled hot reloads, so we could do all that graphics tweaking. Fixed the bug with creating breakpoints, and fixed the bug with the title bars being misaligned. Ugh. to do. So they weren't all minor bugs, so I won't say that. How about fix assorted bugs, and I'll just list them. Where was I? Watching threads panes. Fixed rendering of currently executing. So repass here doesn't repass binary file anymore. I put but there. Okay, that was, which was that? That was that bit. Then here, what we're doing, I've already forgotten. Update and prepare render set. Okay. Switch this binary disassembly view when we switch source file. Fix debug. How am I going to explain this? Enable break. Fix a bug where breakpoints could not be set in shared library code. That's that last bit. And then finally we had fix a misalignment of the title of the panes of the screen dimension, the screen dimension that is allowed for panes. They were overlapping with the status bar, which I'm not actually using. Done. Right, and that is all for today, I think. Oh, hello, McSteve22447. I'm just about to finish up, but if you have any questions, or you want me to quickly demo anything, just let me know in the next couple of minutes while I pack up. kind of want to leave myself a note of the next thing to do just before I finish. I feel like fixing the disassembly pane would be a good, the memory disassembly pane would be a good idea, because that will actually crash the thing. So there's 2 crash bugs I've got at the moment for things I haven't finished. One of them is this code. In fact, I have a to-do here. I have just implemented position-independent code shared libraries, and now it's broken. So I'm going to change this to-do to this code is currently broken for shared libraries, and switching to this pane at the wrong time will crash the debugger. Next job update this code to use instruction offsets, etc. To properly calculate addresses for libraries, etc. Okay, no questions from McSteve, so I'm going to change this to my actual Twitch handle there rather than my username on this machine, which, as you can see, is MJT. I'm not going to commit that change, that's just there to give me a note. Just put some stars around it. Hopefully I will spot that when I unsuspend this machine. Thanks very much for joining me, and have fun programming, and I'll catch you again next time I stream. Unfortunately, streaming has been a little bit erratic, so I can't predict when the next one will be, but my best guess is Thursday evening. Yeah, thanks, and bye.